Section 4.3, System of Linear Equations in 2 and 3 variables, but in this section we're going to see some word problems or applications. So now that we have learned how to solve system of linear equation in 2 variables in section 4.1 and 3 variables in section 4.2, let's see how these guys apply in real life. Like, what would be the application of this kind of problems at this level of mathematics? Our first problem is the following. One serving of lemonade has more sugar than serving a Coca-Cola. Lemonade has 17 fewer grams of sugar. Remember, fewer means subtract. Then twice the amount of what? Coke. So lemonade has 17 fewer grams of sugar than twice the amount of the Coca-Cola. The difference in the amount of sugar in lemonade and Coke is what? 8 grams. Determine the amount of sugar in one serving of lemonade and the amount of serving of sugar in one serving of Coca-Cola. All right. So what I like to do, instead of solving this equation, this word problem in terms of one variable, I'm going to introduce 2 variables. So I'm going to say let x be the amount of sugar in one serving of lemonade, and let y be the amount of sugar in one serving of Coca-Cola. So the first one says the amount of sugar in lemonade is 17 grams fewer than twice the amount of Coke. So there it is. So that means x is equal to 2y minus 17. Notice I didn't write 17 minus 2y. It's 2y minus 17. Okay, and the difference between the amount of sugar in lemonade and Coca-Cola is 8 grams. Difference means subtraction. So lo and behold, what did we come up with? 2 equations, 2 unknowns. So the idea is, how would you go about solving this? Well, turns out, if you remember from section, 1.4.1, what you could do is kind of like multiply both sides of, let's say, equation number 2 by -1, correct? So that way you can add the equations and x's disappear. So you get 3y is equal to what? Y is equal to 25, so that would be like the amount of sugar in Coca-Cola. Now if you go back to equation number 1 and replace the y with 25, x would be 33. So there are 33 grams of sugar in lemonade, and 25 grams of sugar in Coca-Cola. Notice, because I introduced 2 variables, so that's why I came up with 2 equations. So the number of variables depends on the number of equations depends on the variables you introduce in any word problem. The next one is a motion problem. So here it goes. John Lee, in his Piper Cup airplane, flew an average of 120 miles per hour with the wind and 87 miles per hour against the wind. Determine the speed of the plane in the still air, that means calm air, and the speed of the wind. Remember, the speed of the plane with the wind is the speed of the plane in the still air plus the speed of wind. And the speed of the plane against the wind is what? The speed of the plane in calm air minus the speed of the wind. So what we do, or what I did, I let x be the speed of the plane in the still air and y be the speed of the wind. So, right? So, he flew on an average of 120 miles per hour with the wind. So that means x plus y is 121. And against it, it was 87. So x minus 1 is 87. So remember, when the plane flies with the wind, so its speed is speed of the airplane in calm air with the wind. If it goes against it, is speed of the plane in calm air minus the speed of the wind. So now once again, you have two equations, two unknowns. Notice the y's have opposite signs. If we just simply add these guys up, lo and behold, the y's cancel, so you get 2x equals 208. X is equal to 104 miles per hour, speed of the airplane in still air. If you go back to equation 1 or 2, you can find y, and y turns out to be 17 miles an hour. So the speed of the wind was 17 miles an hour, and the speed of the airplane in calm air, that is, was 104 miles per hour. Very nice. So next one is a mixture problem. Frank needs to apply 10% of liquid nitrogen solution to his flower garden, but he only has 4% liquid nitrogen solution and 20% liquid nitrogen solution available. How much of the 4% solution and how much of the 20% solution should Frank mix to get 10 gallons of 10% solution? Remember, this is the desired outcome, so that has to go here in the mixture. Remember, this guy is what? The mixture box. Is that right? Usually, what goes usually there is the desired outcome. In other words, he's hoping that he would get what? 10 gallons of 10% solution. There goes 10 gallons and 10%. But what does he have available? Solutions 4% and 20%, but we don't know the amount of these two solutions. So what I did, I said let x be the amount of 4%, let y be the amount of 20%. So x gallons for 4%, y gallons for 20%. Once again, because I introduced two variables, so I need two equations. There they are. X plus y is equal to 10, correct? Because the sum of the solution should add up to 10 gallons. And the amount of nitrogen in its solution is what? You multiply the amount by the percentage. So this would be 4% times x plus 20% times y equals 10% times 10. Remember, 4% in decimal is 0.04, correct? 20% is 0.20, and 10% is 0.1. So to solve this equation, notice once again, I came up with two equations, two unknowns, yes? To solve that equation, what I did, I multiplied both sides of equation number 2 by 100, so I can move the decimal points 2 places to the right, so I can come up with whole numbers. Do you see what I did? Multiply both sides of equation number 2 by 100, so we can move the decimal points 2 places to the right, and lo and behold, you get this. So why did I multiply by 100? Because each of these decimal numbers had 2 places of these numbers had 2 decimal places. Okay, so what I did at this point, here is equation 1, here is equation 2. I multiplied both sides of equation number 1 by -4. Why did I do that? I was hoping to cancel the x's. So when you do, the x's cancel, you get 16y equals 60, so y equals 60 over 16, which is 3.75 gallons. Now, if you go back to equation number 1, let's say this guy, then you can find x, which is 6.25. Notice it makes sense. 6.25 plus 3.75 gives you a total of what? 10 gallons. Now, the next problem is simple interest rate problem. So here's the problem. Jed invests a total of 40,000 from an inheritance in 2 different investment, a certificate of deposit, CD, and a money market account. The CD pays 1.1%, the money account pays 0.35% simple interest. If after 1 year, the total simple interest from both investment adds up to $376.25, find the amount Jed placed in each account. So here is the usual table for interest rate problems. Remember, you write the formula backwards. So this would be principal times rate times time equal interest. Okay, so what I did, I said let X be the amount invested at 1.1%. Let Y be the amount invested at 0.35%. So this is X, that's Y. But remember, to change 1.1% into decimal, you move the decimal point 2 places to the left. So you get 0.011, then you drop the percentage. To change 0.35% into decimal, you move the decimal point 2 places to the left, and then you drop the percentage. Okay, that's what these guys are. And the time is 1 year because the problem said so. So what you do, you multiply these 3 boxes and put the answer in the fourth column here. So this would be the amount of interest. But guess what? We do know what the total amount of interest adds up to, 376.25. So I go 0.011x plus 0.0035y equals 376 bucks and 25 cents. But notice the total amount of investment was 40,000, so that means x plus y was 40,000 bucks. And this guy was what was it? 376.25. So I have the total amount of interest and total amount of investment. So once again, you have two equations, two unknowns. Here goes equation 1, there goes equation number 2. So what I did, I multiplied both sides of equation number 2 by, well, you guessed it, 10,000. So 10,000, okay, 10,000. What does 10,000 do to the decimals? It moves the decimal point 4 places to the left. So notice if I have 0.0011, so 1, 2, 3, 4. So I gotta add 0. So what's going to happen is I'm going to get 110, and that's what this guy is. Do you see it? Right? So that's what 10,000 does to the decimal points. It moves the decimal point, 1, 2, 3, 4. So that guy becomes just 35y. So anyways, so this is what you get after you clean up the decimals. And then you can perhaps multiply the top equation, say, by negative 110, correct? Why would I do that? To cancel the x's when you add up the equations later. So we get negative 75y is equal to negative, what is this? 637,500. So you divide both sides by negative 75, you get 8,500 bucks at 0.35%. Remember, the total was 40,000, so subtract this from 40,000, you get 31,500 at 1.1% account. And that's pretty much how you solve simple interest rate problems. But then we also have word problems which you might introduce 3 variables, such as this guy. In 2012 Summer Olympic in London, England, the countries earning the most medals were the United States, China, and Russia. Together, these 3 countries earned a total of 274 medals. United States earned 16 more medals than China. Together, the number of medals earned by the United States and Russia is 10 more than twice the number of medals earned in China. Determine the number of medals in each country. Once again, because there are 3 unknowns involved, so I need to introduce 3 variables. What does that mean? I'm going to set let X be the number of medals earned by USA, let Y be the number of medals earned by China, and let Z be the number of medals earned by Russia. The total number of what metals combined earned by these three countries was 274. The total means add up the number of metals. Okay, so that's equation number 1. But remember, because I have 3 variables, so I need to come up with what? 3 equations. The United States, that means X, 16 more metals than China, so that's 16 plus Y. Remember, Y was the number of metals earned by China. And finally, together the number of metals earned by what? United States and Russia, that means X plus Z, equals 10 more than twice the number of metals earned by China. That's 10 plus 2Y. Once again, you got 3 equations, 3 unknowns. So now we like to what? Solve for X and Y. What I did, I substituted equation number 1 into equation number 1 and 3. So I went to equation 1, and 3, I replaced the x's with what? 16 plus y, and this is what I came up with. So no more x's. So now this takes us back to section 4.1, because now you have 2 equations, 2 unknowns. After combining like terms, you get this. So go ahead and what? You know, kind of like what I did, I kind of multiply both sides of this equation, both sides by -1. So I can have what? Opposite signs for z, so I got the y. Then go back to either of these equations, find z. Then go back to whichever equation has x, find your x. And I came up with x is equal to 104 metals for USA, 82 metals for Russia, and 88 metals for China. And they should add up to what? 274. And finally, we have a mixture problem, but we are mixing 3 solutions. Problem is an 8% solution and a 10% solution and a 20% solution of sulfuric acid are to be mixed to get what? 100 milliliters of 12% solution. If the volume of the acid from 8% solution is equals the sum of the volumes of the acid from the other 2 solutions, how much of each solution is needed? So this is what I did. I said, let X be what? Amount of 8% solution, Y be the amount of 10% solution, and Z be the amount of 20% solution. Because I introduced 3 variables, so I need 3 equations. So here are my boxes. Remember, we used to have 2 boxes. Now we have 3 boxes added to each other in order to come up with what? The mixture box. Do you see it? So that's called mixture box. So what is the desired outcome? 100 milliliters of 12%. But what do I have available? I have 8%, 10%, and 20% solutions available. But I don't know the amount of these solutions. That's what I'm trying to find. So I let X be 8%, Y be 10%, Z be 20%. There they are. So now I need 3 equations, correct? 1, right? 2, and 3 equations. The first one is what? The sum of these solutions should add up to 100. So just add up the top of the boxes and set it equal to the 100 milliliters. There it is. The second one says right here, if the volume from 8%, which is X, equals the sum of the volumes of the other 2 solutions. That means if X is equal to Y plus Z, that's equation number 2. And finally, I want to find the amount of acid in each box. So what do? I take the amount of solution and multiply that by the percentage given. So this would be like 8% times X plus 10% times Y plus 20% times Z equals 12% times 100. Remember, 8% is the same as 0.08, 10% is 0.10, 20% is 0.20, 12% is 0.212. So change these guys to decimals and then try to solve for X and Y and Z. So what I did, I kind of multiplied both sides of this equation, by 100 to move the decimal points, 2 places to the right, so I can come up with nice whole numbers for equation number 3. So what I did, I noticed that x is equal to y plus c, so I substituted 1 into 2 and 3. What does that mean? I went to equation number 2, I replaced this x with y plus c, and that x with y plus c, and lo and behold, I came up with equations number 4 and 5. But if you clean those guys up, you get this. So if you kind of do elimination and find all the variables, you will end up with y equals 20 milliliters, x is equal to 50 milliliters, and z is equal to what? 30 milliliters. And notice it makes sense because they should add up to 100 milliliters. Thank you.